Hello everyone, myself Sowmya. I'm from AML IoT department. Today I want to discuss with the basic concepts of machine learning. So where I start is what is machine learning? It's a set of instructions where the my artificial intelligence system need to work. So I'll give a set of instructions through the different kinds of programming and predicate languages. Today I just discussed how the machine learning work with the AI system I combine with the set of languages. So the definition of machine learning language is learning from the data, meaning teaching computer how to recognize the patterns and predict the external result without any explicit error rating and very easy way. So here, where what we achieve it, learn the relationship between the different kinds of data values and generalizing new data and predicting the new kind of values and improving the day-to-day performance from the last predicate values. So whereas coming to the machine learning, we'll say different categories of machine learning languages we are following nowadays. So we'll say first one is supervised machine learning language. It will label the data depend on the what is the trained data previously we have. Depend on that, it will create the labels. Labels also we will provide, and just it is segregate and sort it out the data with the different kinds of labels what we given previously. Whereas coming to unsupervised language, it discovers the structure of whole trained data and it will label it out. Depends on the how many times it is repeating. So labels also created by the algorithm, and even though train depends on the trained data what we given externally. Its example is customer segmentation. So we have different kinds of recommendations when we purchase something. So we will say trend analysis in the best example. When reinforcement learning is learned by a trial and error method. So he just try the it will predict the one value, and if we say it is not fit into our value predicted values, and it will change and giving the another value of data. So here I can say example is game playing, online chess play. So it will predict, it is analyze the patterns of the how the other person will play along the human being play with the system. Depend on that patterns, it will observe and it will move the next move of the chessboard. Next one is semi supervised, mix of labeled and unlabeled data. So here we say example is web page categorization, like static or dynamic, how it will work. Next one is a self supervised. Here we generate the labels itself by observing the data. Then it will train the data depends on the labels. So masked language models, different regional languages, how we predict that. So number of repetition depends on the number of repetition. We will say supervise that. Okay, it's a set of new kind of language, so we can label it as different in a different way. So next, coming to the pipeline process of machine learning, how we will work on the machine learning. The first step we is doing is data collection. We will collect from the trained data from the given data set values, and next step is data cleaning and pre-processing. So here we use the pandas and all different kinds of packages and different kinds of programming platforms, depends on that. So we will clean the data and we will acquire the what are the parameter actually we wanted to define the decision. Next one is future engineering. Future engineering is depends on the what is the expected value, how we are expecting here. From this we are expecting any reports or any kind of future labels or and patterns what we are expecting, that comes under future engineering. Where the model selection and training. So here the depends on the future engineering what we need to predict or what we need to analysis. Then we will select the model how we need to use, either we use a supervised or unsupervised, and different other kinds of data models we can check. Next one is by choosing the supervised or unsupervised kind of models, we will evaluate and tune the system to predict the new values. Like when we train the data, it will tune to that kind of labels. So next, when we give the new kind of data, it will automatically segregate, depends on the tuning labels. Next one is deployment and monitoring. So this is the endpoint of the machine learning pipeline. Here we just deploy the reports what we generated using this kind of model and algorithm. We are used it into the real-time applications. Whereas first phase includes the data collection and preparation. Here the gathering, first step is gathering. We gather the relevant data from the either log files or data sets or different kinds of surveys, or if it is hardware is included, we will use different we will grab the data from the sensors. Handling the misvalues, outliers and inconsistency. Here next step of the data collection process, we will concat the noisy data. It's a kind of like misused values, misplaced one, and where the parameters are very high, then we these kind of data values we are concatenating. And next one is normalize the scale of numeric features. Here we calculate the means and averages, what are the required parameters what we need to perform on the further operations. Next one is encoding. So completely data set is it's a raw data, so we will encode the data into different format so that nobody will understand. For the security reasons, we do it encoding process. Next one, future engineering. Here create the new variables. If we required anything, we will combine two or more parameters and combine. We will create the new label or new domain, like that. Like here I mentioned the examples of age groups, rolling averages and interaction terms. Next one is demonstrate the reduction, like different kinds of heat maps and all these features. If we wanted to show some graphical representation, these are the main things we will add it in the future engineering. Next one, model training and evaluation. Here we split the given dataset into trained and testing, validation, these three parts. Generally we will use the testing data and trained data. It's like a morely 2/3 is the training, 1/3 is the testing from the given dataset. So here the next step, the first step we will see how we will decide which is trained data and which is tested data. Then we go to the next step, we select the choose the algorithm. So what kind of prediction we are doing, or what kind of end results we want, depends on that. We will use linear models or tree types and neural networks. Depends on those algorithm, different models. We will choose the algorithm what is best fit into this kind of functionality execution. Next, train the model data. By after choosing the algorithms like a linear regression and different kinds of algorithms, we choose the minimizing for loss functions. So what are the minimized error value we can achieve by using that algorithm? So that means efficiency, like generally we'll say 80%, 90% of efficiency is there after using different kinds of algorithm. So we will see the highest efficient algorithm, we take it. Next, evaluated metrics. So here to achieve this efficiency, we use the different kinds of metrics. For the each and every algorithm individually, we have a different kind of metrics to work on the end results. Next, use the cross validation, ensure the robustness. So we can't use a single algorithm, we can use the different kinds of algorithms for the same set of data, and we will find the different parameters, how the parameters will work, everything in the option 1 of algorithm, option 2 algorithm and option 3 algorithm, so that we will decide the best one. We can choose the best one as the best for the best results. Next one is some real world examples. Here we mentioned all as we already discussed in the previous slide. Here this comes under supervised. Here the spamming detection in the email. It is if it is labeled as spam, it will goes to spam. If it is not labeled on the spam, it is goes to inbox. So these are the labeled and unlabeled kind of thing workout. And movie and music recommendation. So generally when we use the different kind of music platforms, we were recommended different kinds of music, depends on the mood selection. So we can observe the emotional patterns of the particular client, so that we can recommend it easy way. So this is a labeled unlabeled prediction. Next one is the predictive maintenance of manufacturing. So here depends on the previous previous years of data, so that we can predict the future, how much we can predict the our manufacturing units will be. Next, crop yield and further smart farming. This is also works same, depends on the previous data. We can analyze that right now how much water levels are there, and the soil depends on these parameters. We can say how much yield we can predict from the right now these farms. Next one is facial recognition using smartphones. So these are the AI vision models, AI vision, different kinds of AI vision models we can use, and we will collect the data, and depends on that our face coordinations, we can predict the face and recognize the face very easy way. These are the some real world examples right now we are working on the by using machine learning. Next, machine learning is a basically four kinds of combinations we can say categorized. One is depends on the output, it is the regression and classification. Depends on the linear approach, what we can say, if it is labeled we can say supervised. If it is unlabeled or you can give a bunch of data, we can say unsupervised data. If the prediction of output is continuous output like x1 x2 until xn, if it is a continuous output we can say regression. Classification is like a decision making, either yes or no. The point will be not in between, either yes or no, like email is spam or not. Only 2 points we can classify that. We can depends on the which area the point is allocated, then we make a decision. Whereas coming to the supervised machine learning, here we say labeled data and labels. So here I taken an example as a bunch of image that contains bunch of different kinds of animals. So I give already labels that detect these three animals from this kind of data what I given here, so that it will run to the one supervised algorithm, whatever it may be. It's like a it's a basic algorithms, so that it pre-process the data. While pre-processing the data, it will collect the label as the input, so that in this entire image we need to only find the animals which is cow and elephant and camel. So these are the three animals we will label it out. Apart from the these three animals, if anything else is there, it will pre-process the data and terminate those kind of images patterns, so that my output is very clear that I want these three animals only. This is supervised learning. So here we will give the raw data along with the labels what we need to predict by using this algorithm. So depends on these three parameters, 1, 2 and 3. We predict the fourth value, what is the end results. Here the supervised learning, the machine learning approach using the label data which is input as the corresponding noun output. So here we already provide the labels and we already provide the data. We expected output will be we already predicted. So we give the input as the different labels and raw data. Algorithm work with to train, and the logic is and after we will get the logic. Okay, next one is the key characteristics of supervised learning. So it always requires the label data, either it may be an input or output base. Next one is algorithm learns from the example and correct the answer. So here already we are giving label, so it will learn from those labels, and given trained data it will correct by using that labels it will correct the data set, and it will arrange the correct way. Next characteristics is can make a prediction or new unseen data. Can make a prediction a new data which is categorized only these labels already given or trained by this algorithm. Next, performance can be measured against the noun correct answers. So here it will work better way in the if it is noun or labeled data already given for the testing, like a learning with the teacher providing the correct answers. So here they won't predict the answers in the answer booklet end of the day. Just teacher will train the student, and the student will go off the exams and write what teacher is teached in the classroom. So here the teaching topic already given as an input, and what question is labeled already given in the output. So just we need to answer exactly what the required here. Next, process training phase. Here we have a training, validation and prediction phase. So first phase is dealing with the AI algorithm lens from the labeled example. So what raw data set, and along with the what is a raw data set, and along with the labels given to algorithm, it is trained now. So and it will sort it out depends on the labels. Next, validation phase. We will give some random animal so that it will label correctly or not. So that's a validation set, test set. So here 1 by 3 is we use for the test, 2 by 3 is for the training. So we done with the training and we done with the testing. Next one is prediction. We give the new data which is under these labels, we can give and it will predict correctly. So that is prediction phase. So supervised learning is basically two types of outputs we can expect from the supervised learning. One is classification, one is regression. So classification is defined labels. We can give it will sort it out, and it will sort it out as a list like 1, 2, 3. The input 1 is comes here, input 3 comes here, input 2 comes here, input 4 comes here, like that it will sort it out. So it's already defined by labels. If I haven't given the labels, then the continuous output will be comes under the different kinds of, like first image it will take. So it will comes under 1 or 2 or 3 or 4. So it will define after checking the testing that image, so that it will match the patterns of the label 1, 2, 3. So if the pattern of the 1 or 2 is matched similar, so it will take the highest matching category. So if pattern 2 is 60%, pattern 1 is 80% matched, label is matched, so that it will decide that this new image comes under this first pattern. So these are the regression kind of unlabeled data. So two main types of supervised classification: input features. Next, output is the labels. Example, train 10,000 of emails labeled as a spam and not spam, so that further coming data, it will easily predict that by seeing the email address it is spam or not. Supervised regression. Input a future of house area and bedrooms, output continuous values, house price. So depends on the house area and bedrooms, both the price will be changed in the different areas. So these two are the labels, even though we can't predict by using only these two values. So area of the price also depends, so that house price will change. So train data is 50,000 of sales, non prices, so that the upcoming house price we can detect easily. Next, advantages of supervised learning. High accuracy will be there if it is a labeled data. Next, clear performance metrics will be there, and well understood the technique, algorithm will work very well. Next, reliable and predicted very similar data if we give respected to the labels. Disadvantages is always having the overfitting issue by seeing a regression kind of outputs, so leading a poor performance with the new data which is not labeled in the what we given trained data. So extract the relevant features and crucial but not time consuming, requires the domain experts in the bias training, may results the unfair predictions. Sometimes when we deals with the regression of no labeled data, this will may lead with the confusion state. Next, supervised learning relies heavily labeled data, which is not can be a costly and time consuming obtaining the challenges. So because we will give the extra input, it will cause the extra execution time, that makes the costlier sometimes if we are handling more larger data sets. So common application are medical diagnosis, convert the speech text and recommended system behavioral depends on the human behavior. We can recommend this. Autonomous driving by using obstacles and sign languages. Next, these are the some kind of algorithms which comes under the supervised learning. First basic one is a linear regression. Next one is a logistic regression. Next, decision trees and random forest, SVM, KNN, know your neighbor node, gradient boosting and Navier Bayesian. These all comes under the supervised algorithms. Next, when it comes to the unsupervised algorithms, we only provide the data. There is no labeling is provided before processing the data. So we just give the bunch of random animals image, then interception, non-output, no training data sets. So here I'm expecting my output is here. So I can give my output should be segregated animals data set. So here I'm giving mixed set of animals which having the image, so that the data itself segregate and work with the algorithm and processing the required output. Here we are not giving any labels. So here the data will goes to here, then it will interception, non-output, no training data sets. Here two conditions are there. We already know the what is output, but we don't know how the training data will be provided. So here next one is the algorithm. Algorithm will work to find out the similarity in the those patterns. It will analyze the image of those animals, then it will check that color and height and all these parameters. Depends on that, it will label itself that some X, it may refer to cow, Y is a camel, and Z is a elephant. So it will label as like this. So it will recognize the patterns, and it will group up the animals like this. Then processing the data, here the output labels we define that different kinds of animals. So here output we already provide the label, it will matches that XYZ. So similar properties it will shows that. So end of the day we will get the results. Definition of the unsupervised machine learning approach using unlabeled to discover the hidden patterns and structures and relations without predefined answers. So here we don't give the any predefined labels, so it will predict the depends on the patterns and hidden patterns and structures of the given properties. Next, key characteristics of the unsupervised learning: works with the unlabeled data. It will easily work with the unlabeled data, and algorithm discovers the patterns depends on independently, not depend on the labels. So like a learning teacher explain in the nature. So like how the learn by doing process will be, we give the set of the data, and so that the students will define that okay, what kind of objective end of the day we are deriving after learning these lessons. So next one, unsupervised algorithms associated with the clustering. Four types of algorithms basically we segregate. So that is one is a clustering and association rule learning, dimensionally reduction, anomaly detection. So whereas clustering comes under like a goal is the clustering identify the patterns and relations which are similar in the given data, so that we can merging these kind of data and keep it one place, so that we can make a one label for those kind of similar data. So example, customer segmentation based on the purchase behavior. So depends on that when we goes to supermarkets, like how the customers are purchasing the one kind of products, like a similar kind of food with a different brands, so that it will analysis the pattern, like how the last 3 months of sales for the same food item but with a different brands, so that analyze these things, and they say that okay, this brand is a topper in the particular food segment. Next one is what are the different algorithms example as a customer clustering. So k-means and hierarchical clustering and db scan is the main three algorithms we can see day to day when we are doing clustering operations. Use case applications such as use case applications are market research and generic sequencing and social networking, different in pattern analysis, so that we can define the different kinds of social objects we can get it out from the different social networks analysis. Next, association rules learning, find the relationship between the different items in the futures. Technique is basically used for the market basket analysis, helps the better understanding that relation between the different products. So we can use we can say simply example here, people who buy the milk also buy the bread. So generally we'll say that if we are using the if we wanted to go for the breakfast, so we find the supermarket nearby, so obviously we will find the one liquid product and one solidated product, so that we can make a bread and milk is a super combination. So this pattern, how they say that this is the best pattern, so they observed whether they are going with the cereals and milk, whether they going the bread and milk, because it depends on different factors, and the price factor will be there, and market availability also there, so that maybe cereals also is a not first place, but it may take a second place or third place, depends on the price market. So next, these kind of algorithms we use in the association rules learning. So these are the FP growth, apiro. Next, dimensionality and reduction. Reduce the number of futures whilst preserving the importance of the information. Here we concat the futures so that we can get the proper predicate, proper values by end of the data. So data visualization and noise reduction. Like here, noise reduction is means we just deleting the unwanted data from the given, like thousands of futures are there, but we really wanted to implement only 10. So that here what are the main 10 important features, we will concat that one by using this PCA algorithm or TSNE. These approaches we use, and the noise reduction we do, and end of the day we concat the 90 labels and we only use the 10 labels as our end results. Next, anomaly detection. Identify the unusual and suspicious patterns. So here we mainly depends on the pattern recognition. So depends on the here mostly I can say this will work for the security and network analysis. So here while we threat detection, simply if I say threat detection is one example. So how we identify the different kinds of suspicious activity, so that that suspicious patterns we can identify and we can say that threat is detected in the network. So here we use the SVM, isolation forest. These are the two example algorithms we can use. We can use more other algorithms, but we this one is a more important algorithm, so for a better approach. Next use case is a fraud detection, system monitoring and quality control. Next, advantages of unsupervised. No need of labeling, so that will cut your cost. Can discover the unexpected patterns even though it is not in the outside output. Next, explore and data analysis. So useful and exploratory. So if we mix with the another data also, it will analyze and pattern define the patterns even though we are not using this data into the our output. Handling large and complex data sets, because here we are not providing any labels, so that we can accumulate n number of data sets, so that we can label herself, the algorithm itself label the data, and it will segregate depends on the what we given in the input. Next, disadvantage. Difficult to evaluate result objectively, noisy data. Because of unlabeled data, there is a lot of noise data will be included in unsupervised language, so that to concat that noisy data, it will affect us more. Next one is may find the meaningless patterns. Sometimes we recognize all the unwanted patterns also. So because of that, we need to save every pattern. It may consider the storage issues and knowledge issues also, and requires the domain expertise to limited guidance. So here it is, we are not providing any labeling. Because of that, we need to know the expertise before getting the results. Next, less precision than the supervised overfitting risk. So here overfitting won't be that much effective in the very small scale, but when we consider to the large scale, it will be may consider overfitting issues, because we are not providing any labels, so that it may sometimes the patterns will be very similar nearby features, so it may consider the sometimes it may happen, so overfitting risk. Whereas the applications are customer segmentation, already we discussed this, recommended system and climate science patterns. Next, where it comes to the output pattern, we are classified into regression and classification. Both are two kind of output patterns by using machine learning algorithm. So when we consider to the regression, it is a algorithm predict the continuous values by using input and features. So given features and inputs, we will predict the n number of outputs. These are the regression. So continuous output will be generated. Key characteristics is output is a real valued number, can be within a range or without a range. If I say, for example, I wanted to predict the pizza price, so I will get the pizza price depends on the nearby market areas or some range like $20 to $30. I may consider, I keep my new pizza as a $22 or $28. Its decision is mine, but the range will be decided. We continuously will get 22 somewhere, 23 somewhere, 28 somewhere. So depends on the trained data, we will the range will may vary. Real world numbers may change. Next, goals, it may change the real world number. Next, goal is to find the best fit line or curve the minimize prediction error. So here best fit line is that like more data points where the line is touching, so that we can predict the proper value of the range of that predicate range. Next, minimize the prediction. That range also 20 to 30. If the real world is price is quoted 28, so the range is 20-30 is a very high range. So we can narrow it somewhere down, like I can say 25 to 30. So that I can easily predict that. Minimization also we will do. Establish the relation between the dependent and independent values. So here the dependent values are predicted by using independent values. Next, use the algorithm that minimize the error matrix and mean square error. So here the error rate should be minimized to get the best prediction value. Next, regression examples is the house price prediction and weather prediction and sales forecasting and medical diagnosis. Evaluation matrix comes under evaluation matrix. We use the mean square error and root mean square error and mean absolute error and R2 score. These are the main parameters. Apart from the other parameters, these are the main things we can make a decision end of the day. Next, these are the main popular algorithms we use get the supervised or unsupervised data. By using these algorithms, we will get the regression output range. So first one is a linear regression, or next one is a polynomial regression, next one is a support vector regression and random forest regression and neural network regression. Next, whereas coming to the next output kind of pattern is the classification. Classification algorithm is a predict the discrete categories, whether proper category boundaries are set it. Class depends on the class or input given input data. Next one is the key characteristics of a classification. Output is a categorical label and predefined class. Depends on the output will be either 0 or 1 or X or Y. So end of the day, the should be classed, or it belongs to either 0 class or 1 class or X class or Y class. Next, the goal is find the decision boundaries separate different from the class. So decision boundaries different in the different class levels. Next, assign the probability and belongs to each class. Next, use the algorithms that maximize the classification accuracy. So we use not only single algorithm, we use 2 or more approaches so that we can minimize the classification. The accuracy, we will choose the best accuracy algorithm as a best value prediction. Next, types of a classification. Whereas coming to classification, here we have a binary classification, multi-classification and multi-labeled classification. So here the binary classification deals with a 0 or 1 or yes, no or yes. Only these are the labels we will define. Next, multi-class classification is a more 2 classes. We will give the label data, so that it will classify either the given image comes under dog or cat or bird. So these are the labeled. Apart from these labels, remaining all we will say noise data. Next, multi-level classification, multi-label as per the instance. So that here we are not giving any labels in the data. So we are just giving the random data consist all the labeled and unlabeled data, so that the algorithm itself segregate this into the X, Y, Z, that kind of labels, so that the output will be predicted end of the day. Next, these are the some classification algorithms. So here the email comes under binary classification because it's say either spam or not spam. Student pass or fail. Next, positive or negative, or cat or dog. So these all are comes under binary classification. Next one is what are the common algorithms we use for the detect the classification. So this is logistic regression, decision trees, nearest neighbor, support vector mission, and random forest. These are the main regularly used algorithms to predict the classification. Next, classification common examples. Next one is the evaluation matrix. By how we define that algorithm is decision is correct or not depends on the accuracy, precision, recall value, F1 score, confusion matrix values, and these all are the labels AUC curve and ROC curve. These all are diagrammatical graphical representation so that we can predict the whether we can do it, the decision is 0 or decision is 1 or decision is prescribably bounded in the properly in a value. Next, popular algorithms are already we discussed that random forest, decision trees, logistic algorithm, all these. So whereas coming to we know the supervised, unsupervised, regression and classification. So these are the output based categorization. So whereas coming to regression and classification, these are the main differences we observed. Output type is a regression, it is continuous value. Classification, it is a labeled or decision making. Next, goals are find the best fit curve or line so that we make a correct decision depends on the range of values defined by the regression. Here the finding decision depends on the boundaries, either 0 or 1 or yes or no, depends on that we make a decision. Example, like price range, spam, like main evaluation matrix here is MSE and RSME and R2. Here the accuracy, precision and recall and F1 score. Visualization, here scattered plots and trend lines, best fit lines and curves. Here decision boundaries, confused matrix and heat maps. Here we can study prediction range, infinite possible values. So here continuous output will be there. We can get the infinite values, depends on that we can fix the one range. Next, it is a fixed set, either it may be 0 to 1 or label X to label Y. In between these only the values will lies. Whereas coming to the depends on the patterns or input values, we will consider supervised and unsupervised. So here the main difference between the supervised and unsupervised, this is the data type. So in supervised we give the labeled base, unsupervised we will give only inputs, we won't give any labels. Goal is we predict the outcomes depends on the labels and input base. Here discover the hidden patterns and label it out yourself, and the end of the day what report the customer or client wanted, we will produce that report. Train the data, learn from the exact correct example, because here we are giving data and labels both, so that it will take both and it will correct the only labeled data only we are saying na, so that means it will correct the data. Next, find the structure of the data. So here we are not giving the labels, so it will label the similar pattern objects, so that it will predict the coming up tested data. Next, evaluation, compare each and non answers. Here already labels are defined, right? So we only predict the non answers. Here we will discover sometimes hidden patterns also, interrupt discovered patterns also. Next, application, here prediction and classification we will mainly concentrate. Here we explore and segmentation, and we will do segmentation means clustering also we can say. So clustering also we will do. Here the accuracy measured by the high, measured and high. Here the normally we will give the only corrected data, right? So accuracy will be very high. Here accuracy depends on the which kind of data we are setting as a input. Here the cost is very high because we are labeling data before sending for the processing. Here no labels are there, so the depends on the comparatively supervised, it is less cost. So here we are ending this topic. Hope you enjoyed this topic. Thank you for the listening.